Good afternoon. Welcome everyone to the Building Security into CI/CD Pipelines for Effective Security Automation on AWS. Must be a catchy title. This is a big crowd. Very happy, glad you could all make it. So before we begin, I just wanted to see a quick show of hands. How many of you are using containers in AWS? Wow, a lot of you. That's great. How many are using ECS? EKS? Okay, that's good. Fargate? There are a few. All right. This will be an interesting session. So the agenda for today's session is we'll start with the need for security, the need for bringing security and compliance checks early into the development cycle, and then we'll quickly turn it over to Kevin. He'll walk you through the approach taken by Flexport. Actually, Kevin, he's the CISO there. And then we'll walk you through the security checks that you can build into each stage of the build, deploy, run phases. We don't want to do PowerPoint by death at this late hour in the afternoon, so we have a couple of demos peppered in there, and then we'll wrap it up with Q&A. All right. So I don't know why marketing does it this way, but our intros come later. I'll go first. So I'm Boreda. I'm Director of Products at Palo Alto Networks, Prisma Public Cloud. I'm responsible for driving product strategy and roadmap for our cloud security products. Prior to Palo Alto Networks, I was at Amazon AWS, responsible for the VPN service and the transit gateway service, which hopefully many of you are using or considering to use. And before that, I was at VeriSign and another CASB company called Cipher Cloud. Over to you, Kevin.
Thanks. My name is Kevin Paige, so I'm currently the CISO at Flexport. Prior to Flexport, I was the CISO at a technology company called MuleSoft that focused on APIs and integration technology. And then prior to that, I spent 20 other years various technology and security roles working for large companies like Salesforce, small little startups, as well as for the government.
Thank you, Kevin. All right, so let's kind of set the stage. I'm assuming there are a lot of security practitioners and security analysts. So, what's the number one security analyst dilemma, or what is a SOC analyst really dealing with, right? Alert fatigue is really a major issue for a lot of SOC teams and security analysts. As you can see by the statistics there, every week there are about 175,000 alerts generated in a typical average enterprise, and only 7% of them are reviewed, let alone fixed or remediated. And if you look at some advanced attacks, it can take up to the MTTR or mean time to identify is about 197 days, and to contain is another 69 days. So the gap between the generation of an alert and full remediation can take a really long time if we just follow the traditional security practices of today. As you all know, security issues start very early in the build stage, and they need to be kind of remediated there. Again, some more stats here. 1 in 2 developers, especially working on containers, they do not necessarily test their security images. That's 50% of developers don't test the images that they are building their apps on. If you look at the top 10 downloads from Docker registry, almost all of them have roughly 30 vulnerabilities on average. And on the flip side, 4 in 10 of those images can be fixed by updating the image tag. So simply flipping a bit will actually take care of 40% of those vulnerabilities in Docker images. And we live in a world of cloud formation templates, automation, and again another statistic based on a research study that Palo Alto Networks did. The number one reason for majority of the alerts. That 62% of the alerts are raised because of a common misconfiguration that could have been caught in an earlier stage of the build, deploy, run, right? And again, with auto scaling, with cloud formation templates, this problem only explodes when there is a common misconfiguration like this. So what I'm going to do next is turn it over to Kevin. Oh, actually, there's one more. So I think the theme here is pretty apparent, right? We really want to build security into earlier stages of your DevOps cycle. That's what is leading up to this DevSecOps momentum. And obviously, this bolt-on security where you're only performing security and compliance checks in runtime doesn't really cut it. And we need a high degree of automation so that we don't slow down the developer. Security needs to be built in every stage of the dev, build, deploy, run phases. So with that, I'll hand it over to Kevin.
Great, thanks, Ram. Cool. Like I mentioned before, I've been doing security for a long time. So I've been fighting the battles, putting out the fires for a long time. A long time ago, I realized that there's got to be a better way to do things rather than put fires out. We came up with the term DevSecOps. It's probably good, I guess, if we talk about what that word is really quickly before I kind of talk about my journey. I look at DevSecOps as just as a standard way on how to make your product or service not suck. Make it reliable, make it available, make sure that you have security inside your processes. Everybody should be using kind of the same tools, the mindsets, the processes. Security shouldn't be an afterthought. Security should just be part of the process. It should just be how it is. It's easier said than done. And how do you get there? And what are some of the lessons that I've learned and thought about as I've made this journey? I've been lucky enough that the last 4 companies I were at were hyper growth. I guess the definition of a hyper growth company is 25% growth in revenue and people. The companies that I've worked at were more than double, so more than 50%. So when you're growing that fast and your engineering teams are growing that fast, your IT teams are growing that fast, it's a big risk, and how do you deal with it? Bolting security on the end while these people are coming in trying to figure stuff out doesn't work. And at the same time, you're bringing all these people on board, the business wants to move faster. Hey, we're doing great. Sales is great. Everything's going great. We need to have more features to make all of our customers super happy. And we're trying to do all this stuff at the same time where internally inside teams, there's not alignment. Between security and engineering teams and IT teams, we're not aligned. Our dependencies aren't quite there. So all of these challenges from a security perspective, as well as engineering perspective, as well as other business units, everybody's not aligned. So how do we get to a spot where we can get everybody aligned and we can figure this DevSecOps thing out? We can figure out how to do ops the right way, right, is probably a better way to put it. So one of the first steps that we had to take is realize that it's not just this isn't a technology problem by itself. It's also a problem with alignment and influence. We want to make sure that all those pieces that were broke, the alignment, the teams that aren't communicating well together, how do we get them working together? Security can't be a bolt-on if security is not going to be a bolt-on. Security's got to get involved. You got to get involved with the engineering teams, with the IT teams, understand what their problems are, and be part of the solution to help them solve their problems while you're bringing security in as part of the standard process. You need to do that through influence. Influence isn't titles. It's not ways to push or use a hammer to hammer things down. It's really just kind of being thoughtful, understanding, and being helpful. And then is the visibility part. So in order to fix things and make people want to know what's going on, you have to make things visible. How are you going to make those things visible? Through monitoring, availability, SLAs, lots of interesting ways to do it. I've done it in a couple of interesting ways, and I'll show you an example here after this slide that showed how we kind of took a look at some of the things that drive certain parts of the business and brought them together so that the visibility was there, and those visibilities drove interesting behaviors. one of the behaviors that it drove was accountability. A lot of times we don't really hold people accountable, and the ability to figure out how to hold people accountable is really important and helps drive behavior changes and helps kind of make operations and brings teams together. The other big thing was identity and access control, getting that right. I think that was really important because in today's age where everybody is virtualized, they're containerized, they're going lots of different directions. There's no such, the old-fashioned asset inventory where you've got a spreadsheet of assets, that doesn't matter anymore. We need to make sure that every asset has got a tag, that everything has an owner, and that there's associated responsibilities with those particular owners. And what we did with a lot of these stories is we figured out ways to figure out what drove everybody. We kind of created a dashboard that identified lots of different things. So we took developers. What do developers care about? They care about how many pull requests are open. We took a look at other things like customer reported issues and incidents, put them on the same dashboard. It drove lots of different people to want to take a look at it. So the security team wanted to look at incidents. We put customer reported incidents on here. The CEO, who was customer obsessed, he wanted to take a look at what incidents were going on, and he wanted to understand what the problems were as well. But we also baked in here at the top of the mechanism. Don't worry too much about the names of the tools on there. Those evolved over time. This is an old version of the dashboard. But we built our static analysis tools into the dashboard. So in the same place that you're looking at incidents and customer reported issues, we're taking a look at static analysis. We're taking a look at dynamic analysis. We're taking a look at what issues were there based on vulnerabilities. We're taking a look at lots of different mechanisms that we could pull via APIs into a single dashboard. And all of these things which you can't see that I cut out of this was that each one of our products had an associated owner for the product, and what would happen is the CEO, the CPO, the CTO would all take a look at these dashboards for their particular item that they cared about. But they would always see that if there was a high-risk vulnerability from one of our product areas, they would instantly ask questions. This held our developers and our product managers accountable for making sure that we had very few vulnerabilities inside the product because they didn't want the CEO or the CPO or the CTO to ask, hey, why do you have 3 critical vulnerabilities inside your product? It's on this dashboard here. What do you need to do to get rid of those vulnerabilities? You need more resources. You need more people. What's it going to take? And that kind of built the culture. It was a strong way to build the culture to make sure that everybody was taking a look at the same set of data. We pulled in across the life cycle of the business some of the most important key assets. We pulled them all in through APIs, and we showed the most important things for people to view that they wanted to see. And this drove a lot of behavior change, and really, instead of me fighting fires and chasing everybody down, people were coming to me, and people were saying like, hey, I see that there's 5 vulnerabilities in this product over here, what's going on? We have SLAs on them, so if it's yellow, that means that it's reaching the end of the age of the SLA. Green, of course, means good, and red means that the SLA had expired. And what do we need in order to get to a good spot where we can keep things as green as much as possible? So using APIs, using automation, and bringing everything together, and really kind of understanding your business users, understanding what drives them, what motivates them, what does the CEO want to see, what does the CTO want to see, what do different parts of the business want to see, be able to bring that into a centralized dashboard using automation and APIs really helped kind of bring this idea of DevSecOps, this idea of operations and automation, and got everybody aligned in a good way and really started to drive good things. It drove a big culture shift. So security was just a thing that people did, and that was just the way that it was. Everybody saw the SLAs and the vulnerability reports, and it led to good behavior. And the accountability drove behavior changes too. So there was less pointing fingers, less like, oh, that's not my fault, that's their fault, or that's not my responsibility, it's somebody else. It was very clear. with all of our assets tagged. Every tag had an owner. Every product had an owner. Everybody knew who was responsible, and everybody knew that everybody had lots of visibility on those that were responsible, and it really helped drive that behavior change. And then building security in increased velocity, so people wanted the features faster. People wanted to build new products faster. Putting that framework in place, using those APIs, providing the visibility, making sure that the most important data elements were visible, really increased velocity. So security really helped, as a security organization, we were able to help a lot of different pieces of the organization come together and really kind of enable through security. So it's a pretty good story. And then there's lots of different kind of vendors bringing new types of APIs to market. Palo Alto's has a couple, and the next portions of this discussion are going to be Ram's going to be discussing some of those APIs for security that you could use to bring to a dashboard to help build into the CI/CD pipelines to increase security and provide that visibility.
I can leave it there.
Whoop, did I go too fast? Sorry.
Yeah, no. All right. I wanted to pick it up from here, right? So how do we help Kevin and his team and customers such as Kevin really achieve these outcomes? While Kevin, kudos to you, you've done a tremendous job of affecting all of these positive outcomes, culture shift, accountability, change in behavior. These are not easy to come. You've accomplished, increase in feature velocity. How do we continue to maintain that? So while Kevin and his team have done a phenomenal job of working on these, we at Palo Alto Networks listen to customers, and Kevin, and we focused a lot on building high degree of automation, and we focused on the tool side of things to help, Kevin and his team. So how did we go about this, right? Now the clicker should work. Okay. All right. So we quickly realized that we need to start security right from the build phase, and we need to make it, developer friendly. As developers are building their applications, we need to provide them with easy, friction-free ways to perform security checks. And this needs to continue, throughout the deploy and run stages. So there are a number of challenges, security challenges that you need to address, especially for containers during each of these phases. And we've gone about it very systematically and built tools. And Kevin mentioned APIs, so we've built APIs so that developers can just hook into our services to perform their security and compliance checks. So let's start with the build stage where you need to be able to perform vulnerability scans on the images that you are downloading from open source or Docker registry. We talked about the fact that 30%, 40% of our top 10 downloads have 30, 40 vulnerabilities. So we need to be able to scan those quickly. And then as you are building your images and beginning to deploy those, we need to scan those images. We need to scan all the configuration settings that are associated with your containers, containerized apps, and runtime security. There are a lot of things that could go wrong even when you deploy a golden certified image and into your orchestration tool, into your registry, and it's spinning up container images, using auto scaling and other features, right? So there are a lot of runtime configuration checks that we need to do. We need to detect any drifts or any new zero-day threats for the golden images that you have, and we need to detect and respond to any potential attacks. So we set out to build a solution or a set of solutions that covers the entire life cycle of a containerized app, starting from the build stage through deployment and through run stage. So how does it all work? So next few slides and demos will kind of walk you through that process. If I can get the clicker to work. All right. So just to take a step back, this is probably the scenario for, if not a lot of you, at least some of your DevOps settings, right? This is where developers are building their applications where security is not really looking into it, meaning they are added only, or they become aware of the applications that you built only after they are deployed in the cloud environment. They are not really part of the daily builds that happen. And this creates a lot of resistance. This creates a lot of frustration both for the developers as well as security teams like the ones that Kevin runs. So we want to go from here, this is the current scenario, to an end state where we want to go from the previous scenario to here where everything's friction free, everything's smooth, because at every stage we are running security is involved, we are running the security team or SecOps defined guardrails, we are running continuous security and compliance checks right from the dev state where you are just identifying your applications through build, deploy, and obviously you're running it continuously during runtime, right? So let's take a look at how how we architected the solution, right? So let's assume you are a developer who's working on your desktop. You are exploring images from a Docker registry. You just pull those down. You are playing with it, looking for a good set of base images and open source libraries that you got from Docker Hub. You need to be able to quickly scan those and make sure there are no vulnerabilities. So you can submit those to the recently released Prisma Public Cloud VulnScan API. We recently released 2 services. They are open source, freely available. So you can start playing with them today. You can start utilizing them today. A developer can simply send the package that you've downloaded into the Prisma Public Cloud. We will scan it for a list of known vulnerabilities, and within a second or so, that's not an SLA, that's the average response time that we see, because that's the response time and performance requirements Kevin's team imposed on us. So within a second or so, we send back either a list of vulnerabilities that we found in that package, or we give a green signal, right? Once you get past that stage, now you started layering in your business logic, your business application, you've built an entire image. Again, you can send it to the same Prisma vulnerability scanning API service and you can set up your CI/CD pipeline to send it automatically to our cloud service. It can be kind of baked into your daily build routine. So as soon as a build is done, it will send the image to our API, and we again send the response back, either a list of vulnerabilities that we found in the entire image that we saw, or and we also send you a list of for each vulnerability the recommendations that we have or the patches that you can apply to resolve those. Let's say again you as a developer went through and the DevOps team went through the list of recommendations we have, fixed all of those. Now your image is quote unquote golden image is pretty clean. Now you're beginning to configure it so that it can be registered with a container registry. You may be using, I think a lot of you said you're using ECS or EKS. You may want to let that orchestration tool spin up your images. But before that, there are a number of configuration settings, deployment settings, YAML files that you need to configure, and a lot of times if they are not configured properly, it opens up a huge attack surface. So we have a config scan service, again available as part of the same Prisma infrastructure as code scanning service. You can submit it there, part of your CI/CD cycle. You can send it or configure your AWS code pipeline, or you can use tools such as Jenkins, any other CI/CD tool. Just make a few lines of code changes in your build script, and every time a build is run, the images get sent the the configurations files are infrastructure as code files, right? These could be cloud formation templates, these could be Terraform templates, they get sent to our service, and again we will scan it, look for, make sure it adheres to all of the security best practices that corporate security team has laid out, a number of industry benchmarks, AWS CIS benchmarks, NIST, HIPAA, SOC 2, so on and so forth. We'll run your infrastructure as code templates through all of those security checks, and then either pass a build or fail a build depending on what we find. And then you are ready to run your containerized apps in these images. So what I'm going to do next is walk you through a couple of demos. Let me set it up. Clicker doesn't, okay, there you go. So I'm just looking at the time. In the interest of time, I had all 4 demos lined up, but I may do 2 or 3 depending on the time we have. I'll start with the a demo where we are going to show how from a Jenkins build tool, I'll actually set it up right there. Sorry about that. Yeah, how we can invoke the Prisma public cloud vuln scan API from a Jenkins build tool and kind of scan your container image, right. So let me swap displays here. So this is a typical Jenkins project. You have set up the Jenkins project to point to a GitHub repository. That's where your source code is. That's where your build scripts are. Every time there is a change to one of these files, so I'm going through and highlighting the call that you need to make. This is the simple API call that you need to add to your build script. And then let's look at the demo. Let's look at the file itself. So we are going to scan this Docker file that I just pulled down from Docker Hub. I'm going to change my build script to include the file that I just downloaded. I'm looking at a curl file, and I'm just issuing a pull request. So this is a pull request because I just changed the curl package to appropriate curl. And this will kick off the build process, and behind the scenes there is an API call being made to Prisma public cloud scanning API, which you can use today, and pretty soon you'll see the build results. I promised about 1 second response time. We built in some pause so that we could get some commentary going. And this is where you'll see the build results. I'm going to open up the console now to look at the build results. So there you go, that build failed. You see the big red check mark, and we will show you why the build failed. So the appropriate curl had a number of CVEs. We failed the build based on thresholds that you may have defined, meaning it should not have critical CVEs. So based on those thresholds, we failed the build. We can take a quick look at what the CVEs are and how we can address them. So those are the recommendations we provide. That's just the CVE, and it just says if you update the version of curl, you should be okay. So we are going to go and update to the curl version recommended there. here is another CVE. So, we are going to fix both of these issues by upgrading to this later version of curl. So, we will go ahead and get that 7, whatever that number is, I can't read from here. So, we will go ahead and change the build script to include the newer version of curl. Just running an update on the package. So, anytime an update is made, there's a pull request and the build script kicks off, and again sends the same package to the Prisma Public Cloud OneScan API. And so, the reason why we made it very simple, there is no authentication required, you can just make it part of your build script, is because we want to minimize that friction for developer. This needs to happen in the background. Once this is set up, it's done, and you'll see the build will automatically pass and we'll be ready to deploy this image. All right, there you go, the build 103 passed and successful. So, I am going to flip it back to slides and you talk about the next scenario. Okay, so we just did that demo. We'll save some time at the end for Q&A. You can ask us questions. We'll stick around for a while. Let's get to the next phase. So, this is where, just like we did with your container images, we can also scan your Terraform templates or CloudFormation templates, anything that you use for expressing your infrastructure as code. Those templates can be scanned by Prisma config scan API, and we'll run it through a number of security and compliance checks, and again provide recommendations if we fail that build. I'm just looking at the clock, so in the interest of time, I won't run the second demo. It's very similar to the first one. I'm going to move to the next, the runtime security aspects of it. Sometimes this clicker is playing games with me. All right, so we are just going to skip that demo and talk about runtime. So, you got your golden image running. It's your orchestration tool has taken over. Your containerized apps are functioning well, but you also need continuous security monitoring, continuous compliance checks of your environment. And we have this recommendation for customers where we say apply the 80-10-10 formula. 80% of the alerts should be handled by automation tools and DevOps tools that we just saw. The other 10% should be, this is your production environments where exactly what kind of security guardrails and configuration settings you have. If you find a deviation or a misconfiguration there, those 10% should be automatically remediated by your auto remediation scripts, and only about 10% should really go to a SOC team or a SOC analyst, right. So, we saw about the alert fatigue. We want to minimize that by really making the DevOps teams responsible for their own cloud misconfigurations, their own security alerts. So we gave them a bunch of security tools to take care of that. And the last 10% we want to give it to, we really want to reserve the most advanced type of threats, which can be reviewed by human analysts, security analysts. And even there, we want to do a lot of work via automated, anything that can be automated should be automated, and the information should be presented to a SOC analyst. So what we are going to see now is a demo of a product called Demisto that we have. Demisto works really well with a number of AWS security products as well as Prisma Cloud monitoring. So what you will see is a demo of alerts being raised by Prisma Cloud being sent to Demisto, and Demisto has a number of common playbooks that have been automated, and they will kind of perform 90% of the work and just leave about 10% of the work for a security analyst. So let's run through a quick demo of that.
Once the integration is complete, the alerts from RedLock are ingested into Demisto and are visible to the analyst on the incidents page, where the analyst can view the incident name, incident ID, incident type, severity, status, playbook, when did it occur, and so on and so forth. All these field values can be selected from the setting page to choose your preferences. As we can see here, there is an alert from RedLock on some EC2 instance communicating with well-known ports known to mine Bitcoin. We can also see that it's an M&A server, but we need more details around this alert. To know more about this alert, the analyst needs to go to the investigation page by simply clicking on the alert. That takes you to the 6th section, investigation views, located on the left-hand side of the page. While on the summary page, the analyst can view more details around the alert. In this case, we know that unless this traffic is part of the authorized applications and processes, your instances may have been compromised. The analyst can also view the alert severity, alert source, the recommendation, as well as the alert ID. The analyst can also assign an owner for this incident right from the summary page. On the war room, the analyst can view all the artifacts and can take actions such as marking as an evidence, note, viewing the artifact in a new tab, attaching to tab. The analyst can also add other team members to help with the alert investigation, as well as run commands from the built-in CLI located at the bottom of the page. Now let's take a look at what response actions the playbook has accomplished. The playbook has already run in the work plan. Each rectangular box that you see on the screen is a human action that can take typically several hours. Demisto provides built-in out-of-the-box playbooks as well as the flexibility for the analyst to create their own playbooks from the playbook page. In this case, the response to cryptocurrency mining alert from RedLock is a playbook, which is a task-based workflows to respond potentially compromised instance. So let's see what the playbook has done here. The playbook marks and prints the alert as an evidence, which can be viewed by clicking on this rectangular box. It has opened a ticket in Jira. It has extracted indicators as well as enriched those indicators of compromise, and if any malicious indicators are found during this check, then those IPs are blocked at the firewall. Similarly, we need to quarantine the instances. So the playbook has already accomplished quarantining the instances. So let's see what it has done. It has captured the instance details. It gets the security group details. It takes the volume snapshot, creates a tag for the EC2 instance, as well as changes the network interface security group to Demisto, essentially quarantining the instance. Once the instance has been quarantined after taking backup and creating a tag, the playbook has also initiated a scan on the EC2 instance and also capture running processes and perform memory capture actions, and then send an email to the analyst for the analyst review. Once the analyst has responded, it has updated the ticket in the ticketing system as well as automatically generated an investigation summary report. And this report can be basically automatically sent to email to all the stakeholders. And once all these actions are completed, it sends an alert notification to the security team to the final review and then potentially close the investigation. Now all these actions typically takes several days and hours today. Demisto's playbook can accomplish the same actions within few minutes. On the evidence page, what we have seen here is the playbook has already recorded few evidences for the retrospective review purposes page. Let's go to the related incidents page.
Yeah.
As you see, there are multiple alerts in action, and on this page you can.
I'm going to pause that and flip back to the slides. All right. So hopefully you saw and understand how you can use a SOAR tool. Demisto happens to be a SOAR tool. So you can use a tool like Demisto to really make life of a SOC analyst easier. You know, automate anything that can be automated, present that information so the human analyst is just making decisions as opposed to spending hours collecting information, you know, going from 10 different systems or tools that they have. So that's what Demisto makes the life of a SOC analyst extremely easy. With that, I want to leave some time for Q&A. So let's quickly wrap up here. What we are doing and what we've accomplished so far is being able to automate a number of security and compliance controls throughout the life cycle of your typical applications, especially container applications, from right when a developer is building these applications all the way through runtime, and then we offer continuous monitoring for this. So with that, you can certainly access the services that we mentioned here from the URL here, developers.paloaltonetworks.com/Prisma. We'll open it up for questions. Actually, before I do that, any closing thoughts on what we just saw?
Just I guess a reminder, DevSecOps should be just ops. We should be automating as much as we can. The technologies are there, the capabilities there. What you see a lot of times with automation is that we're streamlining things. We've got good process, we've got good procedures that are repeatable, and this helps enable the business to move faster, whether it's your security team or other parts of the business.
Yeah, thank you, Kevin. Yeah, so we'll open it up for Q&A now. All right.
You mentioned access to the API is public and unauthenticated.
That is correct.
What are the constraints and data sharing agreements around use of the service?
That's a great question. I think we need to kind of data sharing agreements, we need to take it offline. We are, by the way, just so that we are all clear, we are not receiving your actual containers. Mostly it's manifests, images that you are pulling down from Docker file, Docker Hub. It is right now unconstrained, meaning you can submit any number of files. There are no limits. Even in the free version, there are no limits, at least as of now. Yeah, we want adoption. We want developers to start using this right away, and we want developers to use this a lot. Question there?
Prisma, is it just comparing a known Docker image with vulnerabilities, or is it actually looking into the Docker image to see the status of things?
It is comparing to known Docker images, and then we have a research team that is continuously going through open source places and pulling down images, and we are building a library. So it's both, but yeah. As far as the runtime is concerned, where you are actually submitting the Docker images, you are submitting as a manifest, and we are just going through the known vulnerabilities, based on what you scanned before, just like CVEs and vulnerabilities. There's a question back here. So I couldn't hear you properly, but I'll try to rephrase the question. For infrastructure as code scanning, is it just static analysis, or I think you meant dynamic analysis, or you meant, yeah. Yeah, so we do support both CloudFormation templates and Terraform templates today. We are working on other IAC templates in future. It is, you know, both static analysis as well as we do variable interpolation. We will actually, you know, explore what the JSON will look like, or you know, TFT will look like in your cloud environment. Question there?
You mentioned that this was primarily for containers, but does that also mean that that it supports or may support the DMI analysis, or workloads that are on campus?
Yeah, so the vulnerability scanning service is primarily for containers. The infrastructure as code service is for your entire cloud environment. You could have S3 buckets being created, you could have RDS instances being encrypted, non-encrypted, or security groups open. We will look for all of those checks. Everything that Prisma Cloud does in runtime, we are checking for those in your infrastructure as code templates. All right, I don't see any other questions. Thank you all, and don't forget to submit your feedback. I think. Take it.